Hi, everyone. Welcome to the Learning Curve, Scale AI's weekly Tech Talk series. Today's topic is scaling up document processing. Before we begin, just a few housekeeping notes. This webinar is being recorded, and we will send the recording to you via email. We will have a Q&A after the presentation, but if you have any questions as we go through the presentation, please submit them using the Q&A feature in the Zoom. Lastly, we will be sending a survey in the Zoom chat. Please complete it post-webinar. And with that, Pratik, please go ahead and take it away.
Cool. Thanks so much, Hannah. And thanks so much for everyone to joining us today on our Tech Talk on scaling up document processing. My name is Pratik. I'm a forward deployed engineer at Scale. And with me today is Alex, an ML research engineer. We're both on the Scale Document AI team. And today we're really excited to talk to you a little bit more about what customers really need to build out efficient and robust document processing solutions. We'll talk a little bit about some of the existing solutions that are out there on the market today and what doesn't work. And then we'll finally talk about Scale's approach, combining both labeling and fine-tuned machine learning models to really improve quality and help our customers build out the best document processing solutions. So with that, let's talk a little bit about what customers really need to build out really good document processing. So just to kind of keep things on a high level first, as many of you know, document processing is an age-old problem, decades old, in fact, and many mission-critical businesses even today still run on paper documents. We're talking about industries like logistics, financial services, government, insurance, and healthcare. All of them contain really important paper-based document workflows. And the reason is because these documents still contain a lot of the important and critical information that powers business workflows. And so it's important for these companies to be able to extract information from these documents at incredibly high qualities in order to actually power their business workflows and unlock value from that data. So for example, in logistics, bill of lading is a really important and common document that provides a receipt about a specific shipment that actually is occurring. This is very common in freight forwarding or international trade. Arrival notices are important. They provide information about when and where a specific shipment's actually going to arrive. And invoices provide really detailed descriptions about the specific items and goods on a shipping container, as well as their prices, their weights, and their costs. In financial services and insurance, for example, policy documents in insurance, for example, provide really detailed information about the types of contracts and liabilities that are associated with an insurance policy. W-2 forms provide information about the wages and taxes associated with an employer or business. And payoff statements provide details about a borrower and what they owe to a bank for a particular mortgage or loan that they might have taken out. And so this is just a small fraction of the many documents that occur and we commonly see at scale across a wide variety of industries. And these are documents that are important to be processed and to actually extract the information from. So when we talk about what customers actually need and from these documents and what information they need to extract, it really comes down to identifying very specific fields of information on these documents. So again, bill of ladings are really important in logistics. They provide information about a particular document or shipment that occurred in a trade transaction. And it's not just about pulling off all the text off a page, but really identifying information like the port of discharge or where the container is actually coming from, or the description of the goods on that container. And what's interesting is that there are a lot of different data types that actually occur on these documents, and it's important to be able to differentiate between them. So for example, there could be strings, there could be numbers, dates, prices, and so on. And so this variety in both the number of fields, the types of fields, as well as the data types makes it really challenging, but also important for the customer to actually extract the right information from the documents themselves. In financial services, invoices is another great example. And what's interesting about invoices is that they have a lot of different unique features that are different across a wide variety of vendors. So you can imagine working with 10 different vendors, and all 10 of those vendors could have very different invoice formats, which makes it challenging for systems to actually identify and pull out the information. In addition, there are a lot of different high-level fields, for example, the vendor address, which could be composed of, for example, multiple lines, as well as a country code, and so on. And so this nuanced format and information that we oftentimes see in financial services documents like invoices is another example of types of information that need to be pulled out for customers to actually unlock value from their documents. So now let's transition into some of the existing solutions today and why they don't really work. If we look at existing methods for document processing, typically what we've seen is a combination of OCR, or optical character recognition, combined with these hard-coded regex or regular expressions or template-based solutions. The problem is that these methods are very brittle and they're very rigid, meaning that you have to hard code to very specific template formats or document types that exist. And as a result, if you see completely different formats or very unstructured formats, then you have to still maintain a human workforce that is very operationally expensive as well as challenging to maintain in order to fix errors and make sure that you're reaching the quality that you need. And so this is challenging because you're investing in an automation solution, but it doesn't really get you all the way there. And so you still have to rely on a manual workforce to actually process these documents, something that we've seen is very challenging for the customers that we work with at scale. So just to dive a little bit deeper into some of these challenges, if we look at templates or regular expression-based technologies, one of the challenges is that they really only work on fixed set of structured documents. So for example, a lot of these solutions might expect a customer ID for one document to be on the top left. But if the format of that document changes, as you can see on the right, then the solution gets very confused because it's a very different type of document, even if it might look somewhat similar. And so that set of structured changes that occur in these documents makes it challenging for these very fixed, rigid solutions to actually work well. So just to kind of dive deeper into a particular problem that we've noticed with these template-based solutions, this is an actual example that we've seen at scale on the logistics document. And you can see how there's a lot of different text here, but only a portion of it is actually relevant. And so the problem here is that there's a lot of content that you really need to ignore in order to pull out the most relevant information. Again, it's not just about pulling off all the text off the page, but really only identifying the key pieces of information that actually matter. And that's where these regular expression or template-based solutions really fail, is because it's not intelligently identifying what matters in the document. So, another sort of approach is form recognition, right? So these are essentially structured forms that exist, but again, as the name suggests, they only really work for structured documents like tax forms that always look very similar. But oftentimes, both in financial services, logistics, healthcare, and so on, what we found is that there's a lot of different variability in the actual structure of the documents themselves. So oftentimes these form recognition models don't really work well at all. And so oftentimes they'll kind of rely on table detection in particular as their bread and butter for actually extracting information. But the issue is that if the table itself isn't structured, for example, on the right, the color blue is actually crossing multiple cells, then it's not well formatted clearly, then these solutions aren't going to work well at all. And so one thing to highlight here is that this is a very classic problem, is that if you actually have structured documents, but then transition into more semi-structured information that it might exist in a document, that's where a lot of these fixed solutions actually become pretty challenging. So here's an example of that, where we see here, this is actually a real document that we processed at scale. And you can see how it's a very unstructured document. Information's all over the place. It's a table, but again, there's not really much structure to the cells of this table. You can see here that there's account information at the bottom, there's weight, but it's not really organized in a similar way on the right. And so these semi-structured layouts become really challenging to actually deploy a very rigid, template-based solution. And then that's why it's important to start thinking about how you can actually analyze this information and pull out the information from these more unstructured documents in a way that doesn't rely on manually creating templates. If we look at some more problems that we've seen with these types of solutions, one of them is that there are a lot of complicated fields that rely on more intelligent information parsing from these documents. So as an example, if you're trying to pull out a due date from an invoice, it's not just about identifying the actual words due date, but also inferring information from the payment terms, for example, due upon receipt or net 30 that might be seen on an invoice, or even identifying information about the invoice date. And so there are a lot of automated processes where the solutions actually need to infer information about certain fields, which becomes complicated because that's not something that's typically encoded in existing solutions. And the complexity of fields actually exists beyond this. So there are issues like, for example, address formats, being able to infer categories from various documents, identifying and inferring missing fields, and even looking up situations where business logic is actually important for your particular company workflow. So for example, ISO codes is something that we've seen typically in a lot of different use cases. Another problem that is pretty common here is that oftentimes documents just don't come in individual pages, or they're not always the same. So if we see a bundle of documents, sometimes they could be a bunch of different types of documents within one sort of package. And so, rather than just considering each individual page, it's important to be able to link together all the different relationships across the pages in one bundle of documents. And so what Scale does, for example, is really consider the whole document. So for example, look at the relationships between the first two pages and maybe the last two pages in a full bundle, as you can see in the scan to section at the bottom. That's really important because the information is all related. That's why they're bundled. And so it's important for a solution to go beyond just identifying information on each individual page, but more intelligently understanding what that content means across the entire document package. And finally, another error that we typically see is just on a basic level, transcription errors. And so, oftentimes one of the key aspects of document processing is just pulling off the text off a page, right? And obviously doing this very intelligently. But the transcription part is important because you want to make sure that the data that you're actually reading from a document is accurate. But the challenge is that there could be issues where the document's scanned or it's an image from a camera, and so the quality might be low. And as a result, oftentimes the transcription, as you can see, for example, on the bottom left, is very low quality. In addition, there could be situations where you want to be more intelligent about what the transcription actually is. So for example, Swift code on an invoice, there are certain formats for that Swift code. And so you want to make sure you're understanding what the individual letters actually are and if it's representative of what a business, for example, might represent for a Swift number. And so the transcription errors are a common, very classic error, but it's important because it actually affects the types of data that are actually being pulled off a document. So before we dive deeper into Scale's approach for tackling a lot of these problems and really ensuring high quality document processing, I'll show a quick demo of what we actually do and talk about kind of what that looks like under the hood. So this is a dashboard, and I'll show an example for a bill of lading extraction model. And what I'll do is go to Google Images and find a document actually for a bill of lading. So this one actually is empty. Cool. Yeah. So I think this one looks good. This is a typical bill of lading. And again, just a reminder, bill of ladings are a really important document in logistics for providing a receipt of the shipment. So this is a very critical document that occurs in a lot of these international trade transactions. So what I'll do here is download this image. And then I can just go and upload it directly onto the Scale platform. So what this is doing right now is actually submitting the task. And we do have this upload feature on the dashboard, but a lot of our customers, especially for large volumes of documents, they actually use our API. So it's just a few lines of code to submit hundreds of thousands of documents, if not even more, automatically, and it's embedded directly into their workflows. So while this task is being processed by the machine learning model, I'll talk a little bit more about what's going on under the hood. So Scale Document is powered by a technology called adaptive AI, which really goes beyond OCR, or optical character recognition. What's unique about our approach is that we're really robust and can generalize across a wide variety of document formats. And I'll let Alex explain some of the technical details about our machine learning and how it works. But on a high level, what we're doing here is taking the document that's being processed, in this case, it's a bill of lading, and actually understanding all the different relationships and layouts of that page. So again, it's not just pulling off all the text like what a typical OCR solution or template-based solution might do, but really detecting and understanding what a shipper address is, or what a port of discharge is, or what a description of goods is. And that's really important to be able to understand that semantic information using our natural language models to then extract the fields at incredibly high accuracy. And our models are very robust to a variety of different layouts. So we can actually extract fields across so many different variations in font, in layout, even on hard to read documents, which is an example we saw earlier. And once you get that information, we'll then be able to integrate into your workflows, or you can take that information and power your business processes as well. And so that end-to-end pipeline of being able to build out these fine-tuned models that are built exactly for your use cases, but can be generalized to a variety of different templates or a variety of different solutions or document types that you have without you having any setup costs is really important. And it's something that our customers really like about Scale, because they can just send us some documents and we'll deliver them a fine-tuned machine learning model without any setup costs on their end. And it works great on a lot of the documents that they see at incredibly high accuracies. So what I'll do here is I have the task actually pulled up. This is the document that we just submitted. And you can see here, it's actually able to pull out a lot of the information from this document really easily, and it's runs extremely efficiently. So you can see here, there's a bunch of different lines for the description of goods, and our model is able to very quickly identify all of these different pieces of information. Again, something like the quantity, being able to identify that information, or the gross weight, as well as unstructured information in the table, like the container number or the shipped on board date. And one thing to highlight is that this is just kind of an out-of-the-box model that we have. This model hasn't been fine-tuned on these sets of documents, right? I just pulled this off of Google Images right now. But again, what's unique about Scale is that we can really take this one step further by fine-tuning our machine learning models to improve the quality even further. And that's how we're able to get incredibly high accuracy scores for the customers that we work with, to be able to deliver to them a very robust and scalable document processing solution that can work well on any of the document formats that they see. Cool. So with that, I'll hand it over to Alex to talk a little bit more about what our machine learning looks like under the hood, and how we actually power a machine learning-based document processing solution at scale.
Thank you, Pratik. So as you may all know, Scale has been in the data labeling business for a while now. So what it means is that basically we have acquired expertise, and at the same time, we have developed a very mature platform to label data with the highest quality. This is very important because basically high quality data directly translates into machine learning models that are both powerful and at the same time robust. So for this part, I'll be basically walking you through our overall pipeline, from basically labeling and designing the data sets to actually productionizing machine learning models. So the first step of our full pipeline is dataset design. Scale is one of the rare places where we have full control over our dataset, and this is very important. Basically, what is usually done in machine learning research is that people work with open source datasets. However, there are several problems with that. The first problem is that basically these open source datasets are often outdated. So what this means is that the documents that people work with don't really correspond to the current document that are written in the industry. Another problem is that usually the labels are not aligned with what we want to do. So let's say we have a new customer, and this customer wants to extract some specific invoice numbers. Then we might be stuck if basically the open source datasets don't have the label for these specific invoice numbers. Another problem, which is actually pretty major, is that these open source datasets tend to be too narrow. So either they are too small, or basically they are too specialized on one very specific type of layout. And what this means is that they don't represent the whole diversity of documents that we have to work with when we work with big customers. For these reasons, here at Scale, we have decided to work with our own datasets. And because we have full control on the designing of the datasets, we can basically choose how we want to label our documents. To do that, we basically combine our expertise with what the customers want, so that we can extract the labels these customers want to be extracted, and at the same time develop models that are robust to documents that we have never seen yet. Once we have decided how to label the datasets, we actually have to label these datasets. To do that, we have a human workforce. So first of all, we need to train this human workforce, and we have a lot of tools to train these people very efficiently. So one of these tools is called interactive training, where we basically give live feedbacks to our human annotators to basically explain them what are the common mistakes, what are the edge cases, etc., etc. Doing that, basically, we make them deeply understand what is the task at hand, and we are able to ramp up this workforce very quickly. And so once the annotators are trained, they are able to label the assets with a very high quality from the beginning, basically. Once we have trained these human annotators, they start labeling the data sets. So they are going to label a few documents first. And when a few documents are labeled, we can actually train machine learning models on these few documents. Then the next step is actually to replace the human annotators by this machine learning model. This is what we call pre-labeling. So the overall idea here is that once we have a first machine learning model, we can use this model to annotate the documents we haven't annotated yet. And basically, we're going to shift our workforce from the annotation stage to the review stage. This is great for two reasons. First of all, it means we can label documents much faster because basically reviewing takes less time than annotating. And then the second reason is that it's going to increase the overall quality of our data sets. Basically, as we're moving most of our workforce to the reviewing stage, it means more people are going to review the output of the models. So we're going to fix more errors and have the data sets with less mistakes. Once we've done that, basically, we can annotate the whole data sets with a pretty good quality already, but then we have some tools to improve the quality even more. These tools are called Linters. The goal of Linters is basically to make the data set more consistent. So we have two types of Linters. The first type being software Linters. The idea here is basically to implement some rules with some simple logic to make sure that things are annotated consistently. So here are some of the rules we can implement. For instance, we can make sure that every number only contains alphanumeric characters. Another thing we can do is to make sure that fields that have to be attached to a specific item, let's say subtotals, are attached to one and only one item. So basically, there are plenty of rules we can implement. They are very fast to implement, and then we can quickly flag the documents that have problems, that don't respect these rules. This helps to basically get rid of a lot of rules, a lot of errors that may still exist after we have labeled the data set. Once we've done that, basically, we have removed already, let's say 90% of the errors, but there might still be some subtle errors that we haven't been able to catch with these rules. That's why we have a second layer of linters, which is based on machine learning. This is called targeting review. The idea here is basically that we're going to train a machine learning model on the data that we have annotated yet. And because we have annotated most of the data already at this stage, our machine learning model is going to be pretty powerful. Once we've done that, we're going to run our machine learning models against all the documents that we have already annotated and basically compare the output of this machine learning model with the human annotations. Whenever there's a difference between these two outputs, we flag the document and send it to a human reviewer who is going to decide which annotation between the one from the machine learning model and the one from the first human annotator is correct. This helps catch the remaining errors, the main reason being that because our model at this point is very powerful, we can expect that most of the errors made by the models are actually errors that were in the data. So errors that annotation mistakes. And so this really helps to catch the last subtle mistakes that might still exist in the data set we have originally labeled. We have produced a data set with very high quality for the labels, and then we can move on to the next step. So once we have basically created these high quality data sets, we can actually make the most of it by using some methods such as data augmentations. A data augmentation is the method that enables to basically increase the size of the data set. So it really helps when the initial data sets are small, and it makes the downstream models more robust. There are many ways to do data augmentation. On this slide, there's one specific way that really helps. The idea here is basically to take several documents and extract one field per document. So I say from a first document, we can extract the address. From a second document, we can extract the date. And from a third document, we could extract the invoice total. Once we have extracted all these fields, we can put them all on a new document that is totally synthetic. As you can imagine, there are plenty of possible combinations. So it means that we can increase the size of the data sets by 10 times or 100 times. It directly helps the model training and make the models more robust. The reason why it helps so much is that basically by doing that, we're explicitly explaining to the model what matters and what doesn't matter in a document. So once we have done all this, basically, so once we have labeled our data set, making sure that our labels don't have errors, and then increase the size of our data sets, we can train a last model that will be used to serve the customer. And this slide is a brief overview of our model. So the model we're used are actually can be divided into two parts. The first one being OCR. The OCR part basically takes the raw document as input. So it's going to take either raw image or PDF or something like that. And it's going to extract all the text from this document. So as Pratik explained earlier, basically we're doing that in-house because we discovered that fine-tuning this OCR stage on customer data really helps to get rid of a lot of typos that might appear if we use cloud-based OCR services. Once we have done that, basically we have extracted all the text from the document. So we can use this extracted text and the layout of the documents as input to the next model, which is responsible for the understanding and the extraction. So what this model does is basically it tries to make sense of the overall document to understand the content of the document, and then it extracts the information that the customer wants. Another goal of this model is that basically it's going to say how confident it is in its prediction. And if the model is not confident enough, we can add last layer of human review. So there's going to be a human reviewer who's going to look at the output from the model and basically see if it's correct. If it's not correct, it will fix like the mistakes made by the model. This whole pipeline basically makes it possible to reach the highest quality possible with a very, very small turnaround time. Finally, after all these steps, there's like one last step of post-processing just to make sure that the format corresponds to what the customer is expecting. And then we just send our result to the customer. So all this concludes the presentations. To sum up what we basically said, there are three main takeaways. The first takeaway being that large businesses still rely a lot on paper documents. They process them with a human workforce. And the reason why they do that is that basically existing numerical methods fail to deliver high quality. They fail to deliver this high quality because they're either not flexible enough or not customized to each customer. That's why at Scale, we decided to build a machine learning powered document processing, which is basically customized to each of our clients. And because we have this control over the whole loop, so basically from the dataset design, the labeling, to how we productionize our machine learning model services, we are basically able to exceed the quality bar that the large businesses are expecting. So to sum up, with all the pipeline we've developed, we are able to produce high quality models with a very fast turnaround, models which are pretty cost efficient. And at the same time, there is almost no setup burden for the customers.
Great, thank you so much, Alex. As Alex said, we have time for some Q&A. So if you have any questions on what was presented, please go ahead and submit them in the Q&A feature. Just to kick things off, the first question I have is, what's the importance of the labeling step for getting to high quality ML models?
Maybe I can take this question. This is a very great question, by the way. So labeling a data set is extremely important to get a high quality model. What we've seen over and over is that what really matters when we're building machine learning pipelines is the quality of the label that we have at the beginning. So it doesn't matter if we spend a lot of time like building a model. If the quality of the labels is not good at the beginning, it means that the output of the models won't be good neither. So that's why here at Scale, we really emphasize on spending time thinking about the best models, the best labels we could design and labeling the data sets.
Great. If ML model performs poorly on a document, does that feedback get incorporated into the ML model for further training? Can you tell us more about the full ML loop?
Yeah, definitely. So basically the way we work is really, there's this experimentation loop. So there are like a certain number of steps that we repeat over and over to refine the quality of our model and the output until like we get to exactly what the client is expecting. So basically, as I said, the overall loop is designing the labels, annotating the data, and then designing the model, training the model, and finally designing the post-processing. Once we've done that, basically we send our output to the customer. And if they want another kind of format, or they want new labels, or the specifications change a little bit, we can basically go back to the step of labeling data and change the way our data is labeled to then retrain a model to get different outputs that hopefully corresponds to what the customer is expecting.
Yeah, and just to quickly add on to Alex's great answer, one of the things to emphasize here is that we can do this entire ML pipeline of retraining the model and delivering a really high quality deployed document processing solution for a customer without any setup burden on their end. And so we at Scale take care of that entire end-to-end process from both the labeling all the way to the deployment. And even if there are changes to the requirements that a customer might have, or even if we're already in production and we're noticing that in the real world, there are certain situations where we might want to improve the quality of the model even further, we'll continuously do that on our side so that we can continue to boost that quality for the customer without any worry on their end to actually do that maintenance, even when it's live.
Great. Do you have examples of customers Scale Document has worked with?
Yeah, absolutely. So at Scale Document AI, we're really excited to work with some amazing set of partners and customers. Two to highlight that we're especially excited about is one, Brex, which is a customer in financial services. So for those of you who don't know, Brex is building out an entire platform for businesses to manage their financial services spending, as well as credit card management. And one of the areas where Scale has actually worked with Brex is actually powering their new premium bill pay products. And so what we did at Scale is actually deploy a fine-tuned invoice processing model, processes invoices that come through Brex's premium products instantly and extracts all the fields that they need. And what's interesting is that Brex has certain requirements, and we're able to deliver a fine-tuned machine learning model that can extract that information instantly at incredibly high quality. Another customer that we work with is Flexport, which is in logistics, and Flexport's building out the global platform for trade. And what's interesting about our work there is that we were able to deliver a machine learning model to process these very complicated and unstructured logistics documents, things like bill of ladings, arrival notices, and so on. And we're able to achieve over 94% quality and really reduce the time it took for Flexport to actually process these documents from what was originally a manual workflow of 2 days down to just 10 minutes end to end. And so because of Scale's ability to deliver these really fine-tuned machine learning models, we're able to increase the operational efficiency and reduce a lot of the costs that Flexport had to previously spend when handling a lot of the documents that they do. And this is, of course, for very large volumes. So that's sort of two examples of some of the customers that we've worked with at Scale to really deploy these high-quality machine learning-based document processing solutions that deliver on quality as well as fast turnaround times.
Great. Why is fine-tuning models important for document processing?
That's a great question. So basically, there are two ways to approach the problem. Either we don't fine-tune model, which means that we would release a model that is general and try to address the needs of all of the customers at the same time, or we fine-tune a model for each customer. What we've seen over and over is that customers have very specific needs. So for instance, they might want to label some specific invoice numbers or other fields. And then they might want a specific format, or there are a lot of specification that the customer will want that is unique to the customer. So what we've realized is that by labeling and fine-tuning our models for each customers, we are able to provide a quality that is actually much, much, much higher than if we were working with general models.
Great. Do you also have off-the-shelf models for document processing?
Yeah, so we do. At Scale, we actually do have off-the-shelf models for a variety of the document types that we work with across both logistics, financial services, and many other industries as well. What's unique about Scale's approach, as Alex was saying, is that beyond just kind of the ready-to-go models that we have, what's core to our approach is building out these general document understanding models that really are trained to understand not just the text off a page, but really understand the layouts and generalize across a wide variety of document layouts. And this is trained on millions of different examples to be able to, understand exactly what a document is and those really semantic relationships that we talked about earlier in the presentation to really build out these robust document processing solutions. And so using those base document understanding models enables us to really quickly develop really high quality solutions for customers, again, without any setup costs on there, and deliver something that meets their really high quality needs, at a very fast turnaround time. And so that's something that's unique to our approach is, how we have the off-the-shelf models, but then we can very easily fine tune those to build out high quality solutions for our customers and do this very efficiently.
Great. What sets you apart from other machine learning document processing solutions on the market?
It's a good question. So, what we found is that there are a lot of, products on the market that talk about sort of machine learning. I think what's really interesting about Scale's approach is that there's a difference between, taking optical character recognition and stacking on machine learning and any sort of intelligence on top versus actually building out a machine learning based document processing solution from the ground up. So as Alex talked about, we take the entire end-to-end machine learning lifecycle and embed that into the document processing solutions that we actually deliver to customers, all the way from actually taking the data and doing the labeling to actually all the tuning, the fine tuning, but also the refinement and the infrastructure deployment for those machine learning models. And so by taking that end-to-end approach across the entire machine learning lifecycle enables us to build out a lot more robust and tailored solutions to the specific requirements that our customer has. And that's really important. What we found from working with our customers is that they like the ability to fine tune these specific models to their exact requirements, because every company has their own business workflows and their own requirements that they need to be met, right? And so these off-the-shelf solutions don't meet those requirements, and that's why Scale really comes in to deliver on both their high quality requirements that they have to extract information, but do this in a way that leverages machine learning so that it can generalize across any of the document types that they might see in production.
All right, I'm not seeing any more questions, so thank you very much for joining us today. For next steps, we will be sending you an email with the recording. Please tell us what you thought of our talk. The survey link should be in the chat. And lastly, our next Tech Talk is Fireside Chat with Zensiac on June 29th. You can find all the information for the event on scale.com/events. Pratik and Alex, thank you so much for your time today. And thank you everybody for joining us. Have a great day.